Mathematics, Grade 10, Monthly Review, Semester 3. Now, scalar product. Scalar product of two vectors. U dot v is equal x prime plus y prime. U dot v equal norm of u times norm of v times cosine alpha, where alpha is the angle between vector u and vector v. Norm and distance. If vector u of coordinate xy, then norm of u equal radical x square plus y square. If a of coordinate xy and b x prime y prime, then the distance AB equal radical x minus x prime square plus y minus y prime square. Angle between two vectors. Cosine alpha equal x prime plus y prime over radical x square plus y square times radical x prime square plus y prime square. We know vector u and vector v. Find the cosine alpha, find the angle between the two vectors. Cosine alpha equal x prime plus y prime over radical x square plus y square radical x prime square plus y prime square equal x prime is 2 times 3 plus y prime 1 times minus 1 over radical x square plus y square, so 2 square 1 square times radical 3 square minus 1 square, 3 square plus minus 1 square equal 2 times 3 6 plus 1 times minus 1, so right here minus 1 over radical 2 square plus 1 square 5 radical 3 square minus 1 square 1, 3 square 9, 1 and 9 radical 10 equal 6 minus 1 5 over radical 50 equal 5 over radical 50, it is 5 radical 2, so 5 by 5 1 over radical 2. Another expression of scalar product. If vector u is AB, vector v is AC, and H is the orthogonal projection of C on AB, then we can say that u dot v, which is AB dot AC, equal AB times AH. Note that if u and v are non-zero vectors and u dot v greater than 0, then alpha is acute. If u dot v less than 0, then alpha is obtuse. If u dot v equals 0, then alpha is right. And in this case, u and v are orthogonal. Orthogonal vectors. U dot v equals 0. Then x prime plus y prime equals 0. In this case, we can say u and v are orthogonal. Now, polynomial. Zero polynomial. Let p of x equal 5 plus m x squared, 4 minus n x plus p minus 3 equals 0, identical to 0. So, coefficient is equal to 0. 5 plus m equals 0, 4 minus n equals 0, and p minus 3 equals 0. 5 plus m equals 0, so m equals minus 5. 4 minus n equals 0, so n equals 4. P minus 3 equals 0, so P equals 3. Identical polynomial. Find M and P such that P of x and Q of x are identical. P of x and Q of x identical if 3x power 4 equal mx power 4. Minus 5x square is equal P minus 1x square. 2x minus 4 equal 2x minus 4. And last, minus and plus 1 x square equal to 0. So 3x4 equal mx4, so m equal 3. P minus 1 equal minus P minus 1 equal minus 5. So P equal minus 5 plus 1. P equal minus 4. Minus n plus 1 equals 0. So n equal minus 1. Numerical value of a polynomial. P of x equal 2x cubed minus x squared plus 3x minus 7. Calculate P of 1. P of 1 equal 2 1 cubed minus 1 square 3 times 1 minus 7 equal 1 cube 1 times 2 2 minus 1 square 1 plus 3 times 1 3 minus 7. So 2 plus 3 5 minus 1 4 minus 7 minus 3. So P of 1 equal minus 3. We can say that minus 3 is a numerical value of P for x equal 1. Root of a polynomial. We call root of a polynomial P any real number B such that P of P equals 0. Example, P of x equal 5x squared minus 3x minus 2. Does 1 is root of P of x? We say that 1 is root if P of 1 equals 0. Let's try. P of 1 equal 5 times 1 square minus 3 times 1 minus 2 equal 5. 1 square is equal to 1. Minus 3 times 1 is 3 minus 2 equal 5 minus 3 minus 2 equals 0. So P of 1 equals 0, then 1 is root. Divisibility by x minus a. If P of x divided by x minus a, we get P of x, and here remains the remainder. So we can say that P of x is equal to x minus a times Q of x plus remainder. Example, x squared plus 2x minus 8 divided by x minus 2. Multiply x by x to get x squared. X times x, x squared. X times minus 2 minus 2x minus here plus 2x plus 2x 4x minus 8. Multiply x by 4 to get 4x. 4 times x 4x minus 4 times 8 2 8. Here minus and here plus. So 0 and 0. So we can say that P of x equal x minus 2 x plus 4. Now equation of straight line. Cartesian equation. Cartesian equation is in the form ux plus vy plus w equals 0. Its directing factor is minus vu. Write a Cartesian equation in general form passing through a and directing factor v. First, let m xy any point in the plane. Am xm minus xa, ym minus ya. So vector am has coordinate x minus plus 2, y minus 3. find the equation, write xam over xv equal yam over yv. Xam x plus 2 xv 2 equal yam y minus 3 yv minus 5. So minus 5x minus 10 equal 2y minus 6 minus 5x minus 2y minus 10 plus 6 equals 0. Minus 5x minus 2y minus 4 equals 0. This is a Cartesian equation. Reduced form. As we know, ux plus by plus w equals 0. Vy equal minus ux minus w. Then y equal minus u over vx minus w over v. It is in the form of y equal ax plus b. Ax plus b, the form of reduced form. Directing vector is 1a. Example, a minus 2, 3, v, 1, 5. First, find the vector am. Am x m minus xa, ym minus ya, so x plus 2y minus 3. So, xam over xv equal yam over yv. So, xam is x plus 2 over 1 equal y minus 3 over 5. Cross multiplication to get 5x plus 10 equal y minus 3. Reduced form, y equal 5x plus 10 and plus 3 plus 13. To find the equation of a line defined by 2 points. First, find a vector AB, then a vector AM. AB, xb minus xa, yb minus ya, it's equal 5 minus 9, and am, x minus 2y minus 3. Then, xam over xab equal yam over yab. Cross multiplication, minus 9x plus 18 equal 5y minus 15. Then, minus 9x minus 5y plus 18 plus 15 equals 0. Add them. Minus 9x minus 5y plus 33 equal 0. Parametric equation of a line. Also, we need two vectors, am and v. But here we have am equal t times v. T is parametric. Am equal t times v. So, can say that xam equal t xv yam equal tyv. Xam it is x minus x0 equal t xv is alpha. Yam it is y minus y0 equal t beta. Then x equal t alpha plus x0, y equal t beta plus y0. This is a parametric equation. Example, find a parametric equation passing through B and having directing vector V. First, let any point in the plane. Find Bm. Vector Bm, xm minus xb, ym minus yb. So, Bm is xm x minus xb minus 5 plus 5. Ym y minus 2. So, x bm equal t x v. Y bm equal t y v. Then, x bm x plus 5 equal t x of v 3. Y bm y minus 2 equal t y v 4. So, the parametric equation is 3t minus 5 and y equal 4t plus 2. Now, relative position of two lines. Relative position of two lines. First, general form of Cartesian equation. Two lines are intersect if u over u prime does not equal v over v prime. U over u prime equal v over v prime does not equal w over w prime. Two lines are confounded if u over u prime equal v over v prime equal w over w prime. Second, two equation Cartesian of reduced form. Two lines intersect if a does not equal a prime. A equal a prime, b does not equal b prime, then the two lines are parallel. If a equal a prime, b equal b prime, then the two lines are confounded. Parametric form equation. If alpha over alpha prime does not equal beta over beta prime, then the two lines are intersect. If alpha over alpha prime equal beta over beta prime does not equal x0 minus x prime 0, y0 minus y prime 0, then the two lines are parallel. If alpha over alpha prime equal beta over beta prime equal x0 minus x prime 0 over y0 minus y prime 0, then the two lines are confounded. Distance from a point to a line. Delta is a Cartesian equation. A is a point of coordinate xy. Find the distance from a point A to the line delta. D equal uxa plus vya plus w all over radical u square plus v square. Example. Find the distance from a point A to line D of equation 3x minus 4y minus 1.5 equal 0. So the distance is equal 3xa minus 4ya minus 1.5 all in absolute value over radical 3 square plus 4 square equal 3. X of a is 1 minus 4, y of a is 2 minus 1.5 all in absolute value over radical 3 square 9 plus 4 square 16 equal 6.5 over 5 is equal 1.3. And now the exam review. Question 1. Let p of x equal m plus 1 x cubed minus m plus 4 x squared minus m over 2 x plus 2. Calculate m so that 1 is root of p of x. 1 root, then p of 1 equals 0. So substitute x equal 1 in p of x. M plus 1 cube minus m plus 4 1 square minus m over 2 1 plus 2 equal 0. So 1 cube is equal to 1 times m plus 1 minus 1 square 1 minus times m plus 4 minus m minus 4 minus m over 2 plus 2 equals 0. M minus m 0 minus m over 2 1 minus 4 minus 3 plus 2 minus 1 equals 0. So minus m over 2 equal 1, then m equal minus 2. Number 2, suppose in this question that m equal minus 2 and p of x equal minus x cubed minus 2x squared plus x plus 2. Show that p of x can be written in the form of a minus x minus 1 and ax squared plus bx plus c, where a, b, and c are real numbers to be determined. First, divided minus x cubed minus 2x squared plus x plus 2 by x minus 1. Multiply by minus x square times x minus x cube minus x square times minus 1 plus x square. Then subtract, so minus becomes plus, plus becomes minus. Minus 2x square minus x square minus 3x square plus x plus 2. Now multiply by minus 3x. Minus 3x times x minus 3x square minus 3x times minus 1 plus 3x minus plus minus cancel x minus 3x minus 2x plus 2 minus 2 times x minus 2x minus 2 times 2 plus 2. So remainder is 0. P of x equal x minus 1 minus x square minus 3x minus 2. Then A equal minus 1, B equal minus 3, and C equal minus 2. B. Write P of x in form of product of factors of first degree. Does minus 1 is root of minus x square minus 3x minus 2? Let's try. Minus 1 square minus 3 minus 1 minus 2 equal minus 1 plus 3 minus 2 equals 0. Then x equal minus 1 root. So x plus 1 is a factor. Divided minus x square minus 3x minus 2 by x plus 1 minus x times x minus x square minus x times 1 minus x plus minus 3x plus x minus 2x minus 2 multiply by minus 2 here minus 2 times x minus 2x minus 2 times 1 minus 2. So the remainder is 0. Then we can write that P of x equal x minus 1 x plus 1 minus x minus 2. Question 2. The following parts are independent. Part A. Given sin x equal 1 over 3 and x is between pi over 2 and pi. If x is between pi over 2 and pi, then cosine x negative, sin x positive, tangent x and cotangent x negative. So begin. Calculate the exact value of the other trigonometric lines. First, find cosine x. We know that cosine square x plus sine square x equal 1. Cosine square x plus sine x equal 1 over 3. All square equal 1. Cosine square x plus 1 over 9 equal 1. Then cosine square x equal 1 minus 1 over 9. Cosine square x equal 8 over 9. Cosine x equal plus or minus radical 8 over 9. But cosine x negative, then cosine x equal minus 2 radical 2 over 3. Now tangent x. Tangent x equals sine x over cosine x. Sine x equal 1 over 3. Cosine x minus 2 radical 2 over 3 equal minus 1 over 2 radical 2. Cotangent x equal 1 over tangent x equal minus 2 radical 2. Number 2. Deduce the value of A. A equal 3 radical 2 cosine 2018 pi plus x plus radical 2 over 2 tangent minus x minus pi over 2 minus x plus 6 equal 3 radical 2 cosine 2018 pi is equal to 2k pi, so it's 0. Cosine x plus radical 2 over 2 tangent minus pi over 2 minus x, take a common minus, so this plus becomes minus tangent pi over 2 plus x equal 3 radical 2 cosine x minus radical 2 over 2 tangent pi over 2 plus x, it's equal to minus cotangent x, so plus cotangent x here plus 6 equal 3 radical 2. We have cosine x is equal to minus 2 radical 2 over 3 radical 2 over 2. Cotangent x is equal to minus 2 radical 2 plus 6 equal. Now simplify 3 by 3 minus 2 times minus 2 radical 2 times radical 2 minus 4 here radical 2 times radical 2 2 2 by 2 0 minus 2 plus 6, so is equal to 0. Part B proves that the equality A equal sine x plus cosine x all square minus 1 over cotangent x minus sine x cosine x equal to tangent square x equal sine x plus cosine x square. Use remarkable identity. Sine square x 2 cosine x sine x plus cosine square x minus 1 all over cotangent, it is cosine x over sine x minus sine x cosine x equal sine square plus cosine square, it is equal to 1 plus 2 cosine x sine x minus 1 over same denominator multiply by sine x multiply by sine x, so it's equal cosine x minus sine square x of cosine x over sine x equal 1 minus 1 0 2 cosine x sine x over cosine x common 1 minus sine square x over sine x equal cosine by cosine 0, then it is equal to sine square x over 1 minus sine square x 2 square x over cosine square x equal to tangent square x. B equal 1 plus cosine square x tangent square x minus 1 over cosine square x equal minus cosine square x equal 1 plus cosine square x tangent squared is sine square over cosine square x minus 1 over cosine square x equal same denominator cosine square x, so 1 plus cosine square x sine square x minus 1 equal 1 plus cosine square x sine square x, it is equal 1 minus cosine square x minus 1 over cosine square x equal 1 plus cosine square 1 minus cosine square, it is in the form of a plus b and minus b equal a square minus b square equal 1 minus cosine 4x minus 1 over cosine square x minus 1 1 equal equal minus cosine 4 over cosine square x equal simplify minus cosine square x. Part C. 1. Sine minus x minus pi minus cosine x minus 2 pi minus sine x plus pi plus cosine minus x minus 3 pi equal. First, take minus common, minus sine x plus pi. Here also take common, but here minus 2 pi is 0, so minus cosine x minus sine pi plus x, take common, so cosine minus alpha is equal to cosine alpha plus cosine 2 pi plus pi plus x equal sine pi plus x, pi plus x is here, sine is negative and we have minus, so positive sine x minus cosine x minus sine pi plus alpha minus sine becomes plus sine x 2 pi 0, so cosine pi plus x, cosine is minus cosine x equal sine to sine minus cosine minus 2 cosine x 2 sine x minus 5 pi, it is minus sine 5 pi minus x cosine pi minus x minus sine 5 pi minus x plus cosine 2 pi over 2 x, 2x over 2 is equal to x minus pi over 2 pi over 2 equal minus sine 4 pi plus cosine pi minus x minus sine 5 pi is 4 pi plus pi minus x cosine pi minus pi over 2 is pi over 2 minus x equal 2k pi is equal to 0, so minus sine pi minus x, sine is positive and we have minus, so minus sine x cosine pi minus x, cosine is negative minus cosine x minus sine pi minus x, sine x minus sine x cosine pi over 2 minus x, cosine pi over 2 minus x, it is sine x equal minus sine plus sine 0, the answer is minus sine x minus cosine x. Number 3. Consider the family of lines DM. Prove that DM passes through a fixed point E to be determined its coordinate. Number 1. DM m minus 2 x my plus 1 minus m equals 0. So mx minus 2x plus my plus 1 minus m equals 0. Take m as a common. X plus y minus 1 minus 2x plus 1 alone minus 2x plus 1 equals 0. So x plus y minus 1 equals 0 minus 2x plus 1 equals 0. Solve this equation. So x equal half and y equal half. The coordinate of A is 1 over 2, 1 over 2. Number 2. Find the equation of the straight line D minus 1. Family DM substitute instead of minus 1. So minus 1 minus 2 x minus 1 y minus 1 equals 0. Minus 1 minus 2 minus 3 x minus y plus 1 plus 1 equals 0. So d minus 1 is minus 3x minus y plus 2 equals 0. 3a. dm passes through the origin of 0, 0. dm passes through the origin of 0, 0. So m minus 2 x is equal to 0. m is y is equals 0. 1 minus m equals 0. 0, 0, 1 minus m equals 0. So minus m equal minus 1, m equal 1. B. dm parallel to x plus 2y minus 3 equals 0. If two lines are parallel, then u over u prime equal v over v prime. U of dm is m minus 2. U over line is 1 equal m over 2. Cross multiplication. 2 times m minus 2 to m minus 4 equal m to m minus m equal 4. So m equal 4. C. dm parallel to y prime or y. The equation of y prime or y is x equals 0, which is x plus 0y plus 0 equals 0. So u over u prime equal v over v prime. U of dm is m minus 2. U of y prime or y is 1 equal v dm m over v prime is 0. Cross multiplication. M times 1m equals 0. So the solution m equals 0. Number 4. In an orthogonal system OIJ, consider the points A, B, and straight line D. First, determine the direction vector V of straight line D. V is 1 and 3. It is alpha and beta, 1 and 3. Number 2. Show that the equation AB is 2x plus 3y minus 7 equals 0. First, to find the equation of straight line AB, we need two vectors. First vector is AB, xb minus xa, yb minus ya. So xb minus x8 is minus 3, yb minus ya 2. And vector am, m is any point in the plane m of coordinate xy. So am is x minus 2, y minus 1. Find the Cartesian equation axam over xab equal yam over yab. So xam is x minus 2, xab minus 3, yam y minus 1 over yab 2. Cross multiplication. 2x minus 4 equal minus 3y plus 3. 2x minus plus 3y minus 4 minus 3 equals 0. So 2x plus 3y minus 7 equals 0. So it's verified. 3. Calculate AB dot V. AB dot V equal x prime plus y prime. X prime is minus 3 times 1. 2 times 3 equal minus 3 plus 6 equal 3. B. Let I be a common point of D and AB. Calculate the coordinate of I. First, Equation of D is x equal t plus 3, y equal 3t plus 4. Equation of AB 2x plus 3y minus 7 equals 0. 2. X is equal t plus 3, y is equal 3t plus 4 minus 7 equals 0. 2t plus 6, 9t plus 12 minus 7 equals 0. So 2t, 9t is 11t. 9 minus 6 minus 7 minus 1 plus 12 plus 11 equals 0. So t equal minus 11 over 11, t equal minus 1. If t minus 1, substitute x equal minus 1 plus 3 equal 2, y equal 3 minus 1 plus 4 equal 1. So the coordinate of I is 2, 1. C. Calculate cosine alpha, the angle between D and AB. Cosine alpha equal AB dot V over norm of AB times norm of V. 3 over norm of AB, 3 square plus 2 square times radical norm of V, 1 square 3 square equal 3 over 3 square plus 2 square radical 13, 1 square plus 3 square radical 10 equal 3 over radical 130 equal 3 radical 130 over 130. Number 4. Find the equation of delta passing through B and parallel to D. Delta passing B minus 1, 3 and parallel to D. D have a directing vector 1, 3. Let M be any point on the plane. Find BM. BM is x plus 1, y minus 3. XBM over XV equal y of BM over y of V. So XBM is x plus 1 over V, x V 1 equal YBM y minus 3 over 3. Cross multiplication, 3x plus 3 equal y minus 3. So 3x minus y plus 3 equals 0. 3x minus y plus 6 equals 0. Equation of delta. Number 5. Find the distance from A to line delta. Equal. First, absolute value. Equation of delta is 3x plus minus y plus 6 over radical 3 square 1 square. X of A and y of A equal 3. X of A is equal to minus y of A 1 plus 6 all over 3 square 9 plus 1 equal 6 minus 1 plus 6 11 over radical 10 equal 11 radical 10 over 10. Question 5. ABCD square of side 2 and ABC is right isosceles triangle. I, J, and K are the respective points of AB, AD, and CE. First, calculate AD dot CB and CE dot AB. AD dot CB equal AD times CB times the cosine between AD and CB is 180. Cosine 180 equal 2 times 2 C dot EB equal EC dot EB. B is the orthogonal projection of C on EA, so you can write EB times EB equal 2 times 2 equal 4. 2. Consider orthonormal system AAI AJ. AAI AJ. Calculate the coordinate of points A. A is the center, 0, 0. B will be if AI1, so B is 2, 0. C 2, 2. D 0, 2. E 4, 0. I 1, 0. J 0, 1. K 3, 1. B. Calculate the coordinate of CJ. CJ xj minus xc yj minus yc. CJ is xj minus xc minus 2, yj minus yc minus 1. Now coordinate of ID xd minus xi, yd minus yi. Xd minus xi is equal to minus 1. Yd minus yi is equal to 2. Now show that Cj and Id are orthogonal. Cj and Id orthogonal if Cj dot Id equals 0. X prime plus y prime equals 0. Let's try. X prime it is minus 2 times minus 1 minus 1 times 2 equal 2 minus 2 equal 0. Then we can say that Cj and Id are orthogonal. C. Let alpha the angle between DIC. Alpha. Calculate ID dot IC. ID dot IC. First find coordinate of ID. ID is minus 1 and 2. IC is 1 xc minus xi, yc minus yi. ID dot IC equal x prime plus y prime equal minus 1 times 1, 2 times 2 equal minus 1 plus 4 equal 3. Now cosine alpha equal angle between IC and ID, so cosine alpha is equal IC dot ID over norm of IC times norm of ID equal 3 over IC is radical 1 square 2 square times radical 1 square 2 square equal 3 over radical 5 times radical 5, 3 over